I'm Richard Darst. I work at Aalto Scientific Computing, where we support computational research. And the three big categories are computing, so using the advanced computing resources, software, which is both software that other people make and you need to use, but more important for today is software which you're producing inside of your group. And then data. So Jarno, who's here, is also on our team and is a research software engineer, which basically means that his job is helping groups with software, doing all different kinds of activities. But we'll talk more about the role of a research software engineer and how it can help you later. So let's see. I guess would you like to, I guess we can do this as a discussion. Does that sound good?
Yeah, that sounds
okay.
good to me.
So let's go.
So I'm essentially starting this from zero, so I have no idea what I'm doing. But let's assume that I'm starting a research group, which is not that far from a place where I've actually been at some point in my career.
Yes.
So
you're pretending to be a new professor who is starting a group.
Yeah.
Okay. Yeah.
Right. So the first thing I guess the first thing I want to know is why what do you have to offer me? So what why should I watch this video?
So yeah, why care about software? Well, this is why plan in advance. So your group's work is valuable, and this is something that we've seen many times. So as we all know, the members of a research group change practically every 5 years or something like that. Almost anyone that you have now hasn't been here 5 years ago and will disappear in 5 years. And that means that if you don't work carefully on things, then what you have now will all be lost and you'll be starting over. And that's a huge waste of resources and a huge waste of your grant money and time and possibilities. And software is especially complex. I mean, if you have like what you write in a paper, okay, anyone can read the paper and try to do it again. But if you're in this talk, you probably use software somehow. And you don't want every new person to find the papers from 5 years ago and have to do it again from scratch. So what usually goes wrong in a research group whenever someone's not planning on these things? So there's many different things here. So this first one, every researcher starts a project from scratch. So this is actually, I have an interesting story here. So back when I was an undergraduate researcher, someone, a postdoc at the time, talked to me and said, oh, you know, the best kind of projects are something where you have the small model, you write all your code from scratch, and you can simulate things and then get your answers. And you're not getting stuck up in all the other things that other people have made. And well, that was definitely true. So it's better to start with something small. But the problem there is you can only ever do simple things. You don't like work together on or for larger things, and that will really limit you. As we said, people are always leaving. And if you don't work at it, then you'll get to this place where people arrive and you say, oh, find the code from previous PhD student. That will be your starting point. And after several cycles of doing this, it's going to be basically unusable, and people will be spending more time trying to understand what it is and how it works than doing actual research.
So I have a similar story from my own history as a researcher.
Yeah.
So there were more than one long-term researcher who have the attitude that, or just the workflow which they have developed over time for good reasons, that they write all of their own software and essentially take at least most of that with them when they go to another position.
Yeah,
that's one way of solving the problem, but it is not the best possible way because other people cannot benefit from your work, not even in your own group.
Yeah.
And there is also the, I mean, even if you plan to do that, or that's what you have done so far, one important consideration is, do you actually own the software, which we will get into at some point, but not quite yet.
Yes. And on the individual level, I mean, it's basically all goes into time wasted. And especially this last one, how many people have you known that say, oh, I can't share my code, or I don't want to open it yet, or I can't give it to the reviewer who asked for it because it's still messy. And that just promotes the cycle above more and more. So where do we start? So you'll notice that the first half of this talk is not so much about the different tools we use, but how people work together. Because this is sort of the intrinsic problem, I think. So best practices for software in research, I mean, it's the kind of thing that's sort of known, like it's not completely new. But the problem is researchers are so busy and overloaded with all types of things. Like there's too much work to do. And especially this pattern I've often seen. So group meetings, how often is there group meetings talking about results? And how often are there group meetings talking about how people got to those results? So this is basically emphasizing the final product, not how you got there, which would be okay if people knew to focus on the path there and worked on it themselves. But for the most part, people here, like the people we're talking about, I mean, their goal isn't to be a software developer. Their goal is to be a scientist, and the software is a tool to get there. And if we only focus on the science, then these skills are not learned and not lost. So, you know, we have people in the same office who are theoretically mentoring each other, but they're only being told, okay, try doing this in the results, try doing that in the results. And then there's no time or like no mentoring about the code itself. Have you seen this pattern in your work or other people you've worked with?
Yeah, and definitely in my own work as well. It's not that I have been perfect from the beginning, right? Yeah. So there definitely, as a researcher, you spend a huge amount of time. You spend more than the hours you have in a day to get your research done. And the software is definitely a kind of a side issue, even in a field where that's computational at its core. The software is still a bit of a side issue, and the results are what matters.
Yeah. So basically, most of this talk is ways that we will try to get around this. Okay, there's a question.
So when is it a good time to talk about the code? So not when they are still trying various things out, when some results have settled down a bit. That's still a part of the question.
Yeah. I mean, I'd say the sooner the better. And I mean, of course, at early phases, you're not critiquing small things, but thinking, is this sort of the overall thing? And it sort of just keeps it clean and from getting too messy and lets people know that, yes, this will be important in the future.
So I guess there's two sort of main parts in a way. So there is the code, the software that your group has developed that is no longer developing that quickly, that's sort of settled and everybody
Mhm.
can use. And then there is what you are tinkering with that has to do with your current project. And often these are part of the same library, essentially. So you take a big code and you change a small part of it to do the thing you want it to do. So there's one part that's changing quickly, and maybe you don't spend too much time on that yet, but then you do want to maintain the overall structure and have it not break all the other parts.
Yeah. Okay. So after we're defining things, let's talk a little bit about planning. So one of my favorite quotes here, the Eisenhower quote, "Plans are useless, but planning is indispensable." So you may know that different grants and funders require things like data management plans. And I've seen the idea around that the funder should also require software management plans. Well, personally, I think that I'm not a big fan of this idea, because I think there shouldn't be what you're doing and then a data management plan as another thought. There should be what you're doing, which should have the data management plan as part of it, like how the data will benefit society. And then how you do it should be good working practices and not created for every grant individually. So basically the idea here. So you shouldn't wait for a grant and then write a plan and then rely on that for what you're doing. But already, like for your whole group, you should think, okay, so what's our strategy with software? Where do we keep it? What tools do we use? How do we document it? How do we license it? When do we share it? And things like this. And that is what we'll talk about. Well, basically, listening to this talk turns into the basics of that plan. So speaking of this group's documentation area, or are there any other comments here? No.
I don't think so.
Thinking of this is group documentation. So this is basically a single place of reference for all of the best group practices and things like that. And for most of the groups I've been part of, it's a wiki or something like that. So for example, at Aalto University, there's the wiki platform, and a group can request a wiki space from there and start collecting notes and things like that. There are other options like putting it in a version control repository or in Google Docs or something like that, but you know, it doesn't matter too much. But this is where you should start writing down some of these major practices. So you could start with looking at it like an onboarding thing for new group members. Like, where is the group GitHub organization? Where is the internal GitLab organization? Who can you talk to about code issues? What's an index of the existing software and data and other resources? And where can I find them? And if you want to be really radical, can you make all of this information open? So basically people from outside who are looking at your group, maybe thinking of joining, think, wow, like this group is so well organized. They really know what they're doing.
So if we are talking about a new group or a new group leader, I think we're, at least in my experience, we're talking about one project leader and one or two other people,
Right, yeah.
Probably one person in the group.
Yeah.
So it's very easy at that point to have a go through or for everyone, for both people to know everything and have that sort of very direct interaction discussion about what to do in every single situation. But then if you're doing your work well, what you actually want probably is for the project to grow and become something bigger.
Yeah.
Or at least the group to continue and more people to go through it. And then that becomes harder. So starting it from the very beginning, even if your group is just one person, it might already be useful to start documenting how things work. I guess the one thing we say when we talk about software documentation, one thing we say is the most important target of your documentation is yourself in 5 years.
Yeah.
But it of course could be another person who's coming into the project.
Yeah.
3 years from now.
Yeah. And as we wrote here, so I don't think that all the software and data and so on should necessarily be documented in the wiki or wherever, but the software should be documented by itself. And then the group wiki just points to that software. Because then when you're ready to open the software, other people to use it, all the information is there. Okay. So let's go on. The next topic is skill development. And there's a lot of text here because I think this is one of the most important things. So as a supervisor, you're probably so busy with other things you're doing. And also your focus is the science and not the programming or software or data or whatever. But the most important thing you can do as a supervisor is to encourage your group to develop their skills in software development. So not like becoming a professional software developer. Like there's a big difference between what a researcher needs and what a software developer knows. And I don't think anyone here thinks that we need more professional software developers in science. Well, actually, maybe we do some. I should say, we don't think that everyone needs to be a professional software developer, but there is some minimum threshold for what to know. And a lot of that is covered in this Code Refinery course. So Code Refinery runs twice a year online. We have in-person meetups here at Aalto to cover it and to go through the material during it. But if someone knows the basics of programming, which people often learn from their own academic classes, this covers what's needed to connect that to the best scientific practices. And if you send all your group members there and maybe even attend yourself with your group once, then we're basically done. So you know everything that's needed, and we can stop the presentation now. Well, maybe not everything, but that's basically what this presentation should be covering.
Yeah, I suppose the Code Refinery applies these to code, but if you apply all of it also, well, where it's applicable, also to managing your research group, then you're done.
Yeah. So we'd especially recommend attending Code Refinery as a team. So don't send your different group members at different times and everyone's sort of learning alone, but you can actually come together as a team. You take all the courses or all the lessons in the morning, and then in the afternoons, you work to apply it to your own work. And this will really change things. If you do a lot of computing, we have a Aalto Introduction to Scientific Computing, an HPC course, which runs, well, now we're going to be running it once a year because we have good material online. And this teaches about using the clusters and more tools at Aalto. So I don't think that everyone in the group needs to be an expert in everything here, but everyone needs to know like some minimum skill set. But then the groups should have 1 or 2 people who are more of specialists here and can mentor and support the others. And this might even be something which is worth hiring for, someone that's interested in this kind of thing. But courses are just one part of things. And I think that we don't learn most of what we know about software in courses. At least I know I haven't. So most of what I've learned from working with other people who are better than me. And this is one of the reasons we talk so much about the group meetings and these working togethers. So you learn more by working with other people than you learn from the courses. And you need a way that you can do this co-working, that it's not just a bunch of people in an office and they meet for coffee and group meeting once a week. So a story from my background, whenever I was first a researcher, I had a desk right next to my mentor. And thus we were all the time looking at each other's computer monitors, looking at the code, the practice we were using, commenting, trying to run each other thing, teaching each other that way. And that is really important. So it's sort of hard now because, at least from what I've seen for most groups at Aalto, there's just not good office facilities to make that possible. So I don't know how well we can even go here, but it's something that I think we should try to. Have you had any good mentoring experiences?
So yeah, I mean, it's almost a repeat of what you said, but we had in my first RSE job, just for a large part because of lack of space, we just had the whole 6-person team in one office.
Mm-hmm.
It was a little bit cramped, but yeah, I mean, the group development conversations we had at the beginning were, of course, very useful, and we essentially all had them together because we were all crammed in the same room.
Mm-hmm.
We also just ended up talking and co-working a lot with each other about individual projects that were in principle assigned to one person.
Mm-hmm.
That can also be, so you can cause that to happen by sort of officially assigning 2 people to a project, or doing code review and so on, or doing just project review. Of course, it doesn't have to be code. There's a comment.
Yeah, there's a really good comment in chat about someone's most useful mentoring comes from GitHub when contributing to open source projects. So I would also, yeah, actually, this is also true for me. So after that initial mentoring experience I had, basically subscribing to, watching, getting on mailing lists or whatever, reading blogs from other projects, you learn what other people are actually doing. And that is, well, that's invaluable. In fact, once I even heard, does Google Summer of Code still exist even? I think maybe it does, maybe not. But anyway, once I heard a comment about Google Summer of Code, that the reason, so the idea here is that Google will pay students to do basically internships and work on open source projects if the open source project mentors the students about it. And I heard someone comment once that this is basically so that like Google can have open source projects train its next generation of developers and engineers and learn from all these other best practices, which I think says a lot about the value of these open projects. Okay, should we go on? Yeah, so I think I mentioned this before, but now we spent almost half the time talking about teaching and mentoring. And that's because, like I said, the academic background doesn't prepare people for these things. You can't go to always go to the training. I mean, there might not even be the right training offered right when someone joins. So it's not like you even can say, wait for the training and then learn what to do, then start your work. No, that just doesn't work. It has to all come from inside somehow with this mentoring. And since supervisors can't do everything themselves, we need to like create the system where people can learn inside.
And no matter how much time you spend and no matter how hard you try, to document everything, there is a lot that has to come through direct, just working together, advice from people who have been in the group and in the university for a while longer. And I mean, that does apply to basically every job. So you will need to be mentored by your new coworkers, no matter what job you start. It's also true for academics.
Yeah.
But we don't work alone.
Okay. So now let's get to the real stuff, which is software and research. So why do we even use software and research? Well, I mean, when you think about it, computer. So computer used to be a job title, someone that would compute things. And software lets us use a machine do far more computing than anyone can alone. And if it's well made, it transforms research. But also big software projects are one of the most complex tasks that humanity does. So research software is hopefully a lot less complicated than those things. But still, compared to a lot of the things people get training for, it's a pretty complex thing anyway. And there's different types of software we need to worry about. There's the software which is developed by other people, and you need to be able to use it and possibly contribute to it sometimes. There's many groups that are developing software internally, which is what we're mostly focusing on. So things that you write or your group writes yourself and you use inside. And if you make something good inside, then you might want to release it. And when other people use the software, then they will cite you and use your work. And that's really what you want. There's a quote that will come up later, but I was talking to a professor of computer science about software-related things. And this professor said, if we take and we develop some method or model or do some calculation, and other people are not able to have an easy implementation and use it themselves, then our impact and citations will be almost nothing compared to what it could be otherwise. Which really shows the value of open science. And the tools we talk about here are the starting point of open science.
So I guess, I mean, important points are that software isn't just for calculating things. It's not just for data processing. You can automate a lot of tasks that maybe you wouldn't think of doing using software to do, or maybe you don't think of the thing that does it as software, but it almost always it is software if it's happening on a computer. Yeah. And yeah, so we are basically using more and more of it. So I don't remember the stats off the top of my head, but they're kind of old anyway. But a huge majority of research depends on some software that somebody needs to develop.
Yeah. And that's in any field. But I guess the people that are watching this video probably already know that because they're using it. So let's get to the important part, which is the different software tools. So this is sort of the checklist of what you've got. So let's see. Version control is the first thing. So version control tracks changes. So it solves problems like I just changed something and now my code doesn't work anymore. It gets doing the wrong result and I don't know what I changed. So I can admit that in the past, even when I did use version control, I wouldn't keep the record of the changes often enough, and I would make some change. And then suddenly my code is giving me something completely different. And I have no idea if what I just changed broke it or fixed it. And since I don't know what I changed, I'm basically stuck with going through everything to try to get what I had before. And this applies.
And if you don't know if it broke it or fixed it, that points to a different problem that I guess we'll come up to later. But
yeah, yeah. I mean, in these cases, usually I think that I've broken it, but who knows?
But yeah, this is an experience I've definitely had. Like, I've work on some part of it for a few hours or a few days, and then realize that it just no longer works. It somehow does a completely wrong thing or doesn't even run. And well, the two options. If you're using version control at all, you can go back a day and start again. That's kind of the minimum, and that already solves a big problem. You don't need to go hunting for another version of the program from your coworkers or hunting for the bug inside the program.
Yeah.
Of course, version control also helps you find the bug because it shows you the changes.
Yeah.
That's maybe slightly more advanced.
Yeah. And the other thing is, well, this is like sort of short term, but long term, I've never seen researchers as frustrated as when they get paper revisions back and they have to do their results, do their analysis again, and then they get different results and they can't run it again. Maybe they have a ton of Jupyter notebooks and they ran a bunch of cells in a certain order, and now they don't know, like they don't even know how to run their code to get the figures they had before. And I think there's nothing more frustrating than this. And version control isn't all you need to solve this, but is one of the important aspects of it. It allows collaboration. So it solves things like, oh, can you send me the latest version of the code so I can run myself? And if your code was a problem before, now you have two problems because you have two people that might be modifying it and then two different versions. Once you start having all these different versions, there's almost no way to put them back together again. So once you have things in version control and you don't have, and you have people working together, you have what's called a single source of truth. So basically, everyone knows what is the main version. It's what is being tracked. And everyone uses that latest version and contributes there. So of course, that assumes that the code is large enough and stable enough to be used by everyone. And the most common version control system these days is Git. So, yeah.
Right. So, I mean, even if the code for a large part is not stable enough for everyone to be using it in the same way or have it in the same, having the same version of it, there probably is some key part, some key functionality that will stay relatively constant.
Mm-hmm.
Otherwise, it wouldn't be a different version of the same code.
Yeah. Let's see. So our suggestion is, well, unless you have a reason for something else, try learning some Git and use that for your code. Now, Git does not have the best user interface, and it can be downright hard to use, but that's okay. So have everyone learn a little bit, have a few people learn a little bit more, and then know who you can ask for help for more questions.
I think for the first 5 years of my career, roughly, I used maybe 3 Git commands that I just learned by heart to like save my changes, to push them to the to the one ground truth repository, and to get changes from there. And that, well, that's 3.
Yeah, and that's basically enough to keep you from descending into chaos. Yeah. So then once you have Git, it's not something that just exists on your computer, but there are these platforms that host Git repositories and allow it to be shared. So the most common ones are GitHub and GitLab, which I guess Bitbucket coming in third place. But the basic idea is this is the website that holds the code and provides visibility to the world. So GitHub is basically a commercial site. GitLab has a public site also, but is also open source, so can be run inside. So for example, what many groups will do is they will have a public GitHub organization, which allows you to host all the group code together. So these organizations, you make one, and then there's admins, there's members, there's like contributors, and so on. There's these different roles. So with this, yeah, it becomes the central place you can store things, and then every computer is pushing and pulling from there. So then for places like Aalto, that has its own GitLab running at version.aalto.v. So in this case, what you do is you have the internal one there. So the code that's not public or is confidential or subject to NDAs and so on, that's stored inside of the university. And then is more private. And you can move code between these two different platforms.
And well, there's no reason that you couldn't have a public code on the university platform as well.
Right.
It's just somewhat less public because people will not find it from GitHub or as easily from a search.
Yeah. And one of the benefits of GitHub is that since it's the most common place to find software, open source software, research software, things like that, people know where to look and they know how to contribute back to you. The hegemony of GitHub is not great, but well, it is what it is, and it can be beneficial for you if you use it. So after that is the features that are enabled by the platform. For example, issue tracking. So version control platforms provide these things like issue trackers. So you can track, okay, I have this bug, I need this extra request. Oh, and this thing is broken, but we're working on it. So the group can contribute both between itself and then also contribute to other people who might be contributing to the code. Also, you can use these when you need to comment about other software that other people are making. Very similar to issue tracking is change proposals, also known as pull request. So this is a feature of the platforms like GitHub and GitLab. So it's basically a way that anyone can make their changes, make the changes visible to you, but not part of your code. And then the developers on the code can look at that, say, do I want this or not? And then merge it into their code if they want. So it's great for things like, well, I often have projects and I say, oh, there's this bug or it's missing some feature I need. I make a pull request to the GitHub repository and then it will be fixed there. Yeah, and both of these basically come from the platforms themselves and made possible by Git. So after you have some software, there is testing. So how do you know your code is correct? So this is something we mentioned up above. So is something broken or was it working right in the first place? So when you're making code, the most simple, naive way of doing things is that you try running it, you see if the result's right, and then you move on and add the next feature. But when you add feature B, you don't check, is feature A still working? And so on as you get up to many different features into the future. So software testing is a set of tools and concepts where instead of simply running something yourself to test it and see if you work, you make a test case for it. And then the test case is something that can be run automatically later. And then it allows you to confirm that something is still working in the future all the time.
So essentially, when you try running it, that's a test case. But what we recommend you do is you automate it using one of these frameworks. So
Yeah.
whenever you want to check if your software still works, you run a command and it runs all the tests you have ever written.
Mm-hmm. So basically,
make sure that everything works. That should.
Yeah. So basically, in all of our well-developed projects, what you get is people who are like, when you make any change, you run one command and it verifies that everything in the past still works. And the great part is when it tells you it doesn't work, because that means you know where to look, you can fix that, and you're more free to make changes because you don't have this kind of like risk of maybe breaking something. And you don't end up becoming really conservative and never changing and making copies of the code which do slightly different things because of risk of something going wrong. It's absolutely essential. And next is publishing and releasing software. So if you want to share things, the most basic strategy is to publish and, well, the most basic strategy is to have it on GitHub. So often these days people think, well, it's on GitHub, other people can use it, that's enough. And really it is enough for basic things. And if it's easy to do, then I'd rather more people do that than people try to make things perfect and create releases and archives and so on, but do that less often.
So yeah, I want to echo that. And so even if you're planning to make a like proper release at some point and make it really user friendly and really nice, still it's better to just publish it early. Nobody will complain that it's not like perfectly documented and the coding style is not the same across the whole thing and so on. And then you can continue to work it or continue and work it to make it more shiny and easier to use and so on. But way too often it just takes years to get to the point where you feel like it's done in some sense. It's never really done, but releasable. And it would have been useful to a bunch of people if you had released it sooner.
Yeah.
And also other people will help you. If other people are in fact using it, they will help you make it better. They will, at the very least, find problems which you might not have spotted. And they might even help you fix those.
Yeah. I think we're well past the days of releasing software by having an archive file on someone's personal website. I mean, that is just not, that's not going to be seen well. I guess also related to publication release is the licensing. So if you make your code available, that means people can look at it, but they can't modify it and share it on again. So that means that no one's going to use it to create their own projects, and you'll get less citations. And this is the point where we mentioned how usually where you read a talk about software, people talk about all the good reasons why you should choose a open license, but then they say, oh, but you probably can't do this. You have to ask your university for permission to give anything a license, which is really unfortunate. But the good thing is that at least at Aalto University, if you want to make something open source, you just can. And we have information on this, which will be linked here after the talk.
Unless you're at Aalto, don't assume that this applies to you, but I have never worked at a university that didn't do that. So I've always been able to just publish anything as an open source publication.
Officially or? with that.
Officially, yes. A lot of universities have that policy.
Yeah. At least some of the previous places I were, if you wanted to share something, there was some office that would check things for commercialization potential and so on, which is just
Okay.
a huge waste of time. But of course, that was a long time ago, so maybe it's better now.
Yeah, I would assume that those people would be very overworked,
Yeah.
at least in a place like Aalto.
I mean, they're probably not overworked simply because people don't actually do it. So,
Yeah.
you know, who's that actually helping? Okay. So, yeah. So let's
Oh, and
actually
just to go back, something I mentioned offhand about the license. So if you haven't published the software with an open license, there is a concern about whether it belongs or how in what way it belongs to you, what way it belongs to university. And if you change to another university, which a lot of researchers do very often, you should be concerned about that. If you publish it with an open license while you are still at the university where you work on it, then it is open and always accessible to you as well as other people.
Yeah. Okay. Let's go on. Working together on code. So let's make a little discussion here. So what can go wrong if people work together? So one thing which I've seen is that people say, okay, we're working together on code, and someone changes something and it breaks it for someone else. And then you get this motivation to, okay, so let's actually not have the same version. You have your version, I'll have my version. We do our projects separately, and maybe someday we will combine them together.
You
And
do
in
some
reality,
manual merging. When you need a function from another person, you go and ask for it, and then you put it into your version as well.
yeah. So for this, version control and testing and having good standards about your code help. But this is where you start to need some skills to keep it running smoothly. Like someone who can take care of the overall design and how it works. Are there any other major things that go wrong if people work together on software? I mean, there's the things like people keep their software on their own computers, don't share it, don't show anyone. Someone leaves and suddenly it's gone. Anything in chat.
The worst case, it might have been on someone's private folder that got deleted when they lost their account at university. Or it's just so unreadable enough that another person cannot take the changes they made and apply it to another version of the code.
There's an interesting comment in chat with a student-mentor relation. Working on something together might feel like the mentor doesn't trust the student to get the code right by themselves, which
I understand the concern.
Yeah.
I have an opposite experience. Well, I have several opposite experiences. So I've been the student and I've been working together on a problem with a mentor. And the experience I've always had in that situation is that someone is this person is also interested in this problem and not just making me do it.
Yeah.
But it's a question of how you communicate about this.
Yeah. I mean, it's also difficult because of this, like people don't like to be criticized. And in courses, anytime anyone would comment on your work, it's always because you've done something wrong, because in courses, there's a right way to do things. And if someone's giving you suggestions, it's because it's wrong. But that shouldn't be the case in research projects. We should always be striving to work together and making this kind of attitude where people are open to suggestions and work is a major, like a big factor in learning things. Okay, let's see. So now we're coming to sort of a little intermission before the wrap up. So we're talking about some other things, not exactly software related, but important for group leaders. So data storage. So you should discourage single user storage spaces. So always use some sort of common shared space instead when possible. And if not, have the common shared space be the Git repository that people work, and there's only the local working places locally. So at Aalto, this usually means network drives, which are usually used by some remote system, but can also be mounted locally on your laptop, so you can access the files there. Yeah. So what we recommend in our teams, so we don't provide hard drives, big storage space, things like that for individuals. Everything is on one of our central storage locations. And this can be used from our cluster. It can be attached to people's computers over the network, and then everything goes there. Everything is managed as a group directory. So if anyone leaves, we always have the right, based on our policies, to give access to other people. And it makes it easy to see what each other are doing and work that way. So at Aalto, we have different data storage places. So starting from smaller, there's own devices with very few backups. There's the Aalto home directories, which have some small space on workstations. There's the network drives, which can go from tens to hundreds or even terabytes of space, which are large, secure, and very well backed up. So this is the place where any really important data should be. There is the Triton cluster, which has even more space. So we can easily give projects tens to hundreds of terabytes of space. But because it's large, it's not backed up. And then, of course, there's public data repositories, which is the final place for open data, and it can go.
I could also add CSC services, which can store larger amounts of data, so larger than hundreds of gigabytes, for long term and so that it's also public. I mean, ask us or ask CSC if you have that issue, but it is possible to store hundreds of terabytes that are backed up and publicly accessible if you have that need.
Yeah. And computing resources. So there's a big range here. So things go from small and easy to use, like your own computers, to remote servers, to, for example, the big computer clusters that we have at Aalto or CSC and things like that. And if software is well written, it will be easy to move from one of these to another while doing your work. So it is a good thing to consider. Now we're coming close to the end of our time, and let's talk about the final things. So support. So this talk should have given you some ideas, but was by no means a tutorial because there's just too much. I mean, this is not the place to go over all of the details.
It's also the best time to do and read a tutorial is at the time when you need to actually do the thing. So this is not the best time for that.
Yeah, but you know what to look at. So above we gave links to things like Code Refinery or our HPC Kickstart. And that's a good starting place. But just like we talked about how teaching isn't enough, there's mentoring, there's also mentoring between research groups. So if you're inside of Aalto, there's, for example, the Research Software Engineering Service, which can consult with you about any of your projects. And basically anything in this talk, we can help you set it up and walk you through every step of the way. We don't actually think that a supervisor needs to know everything in here. And for data-related things, there are the data agents, which are similar. And actually, the research software engineers are data agents who can help with data-related issues just as well. Yeah. So here's a brief summary, like the very most important things in this talk. So I'd say that you're not allowed to not use version control, to not push these version control repositories to somewhere online. You can't have critical data or material only on your computer. You can't make something that's so chaotic that you can't organize it later. And you're not allowed to go alone and invent everything without help. But also at the same time, you don't have to start everything perfectly. Don't even have to make everything perfect at the end. Good enough is good enough for most projects. And you don't have to know it all yourself. And if you keep these in mind, then you're probably pretty good. And the last thing is a checklist, which group leaders can follow. And actually, I think we should take this and formalize it a little bit better, maybe make a cheat sheet out of it and send it around to people. So with that said, are there any more final questions? In the chat is, again, the material that we are going over. It's not a presentation, so it's designed to be living material. So this will be constantly updated with new ideas and information until the next time the talk is given. Yes, so any other questions or comments? Yeah, I guess we can. There's not many questions, so let's end it here. Thank everyone for coming, and well, you know how to find us more. And we can, so I'll stop the recording and we can have a consultation session right here. So thanks for joining.